Greetings, fellow coders! Astronaut B here, ready to explore the fascinating world of advanced function signatures. Today, we'll take a look at functions with parameters and functions with return values. Using parameters will allow us to provide input to functions, which will in turn change our output or return value. These two slight changes allow us to create functions that are much more versatile, letting us shape the output for different inputs. Buckle up and let's get started. In our coding journey, we often encounter situations where functions need more information to perform specific tasks effectively. That's where functions with parameters and return values come into play. Let's begin with functions that have parameters. Remember, parameters are the inputs of functions. They provide information that the function needs in order to do its job. For example, we once used the move function to make a rocket move in the direction it was facing. Soon, we found that we had to call the function multiple times in order to move more than once, which was very repetitive. We then upgraded that function to provide a parameter, representing the number of times the rocket moved. We could then use move by x, where x was the number of spaces to move the rocket. An example of calling this function would be move by 5, which would make the rocket move 5 spaces forward. So how do we create functions that accept parameters? First, we start by defining a function. For example, we will have a function called flyRocket. As we recently learned, we can define it like this: def flyRocket parentheses. We could also write the method body like this. Each time we call flyRocket, it will print that it flew for 10 minutes. But what if we wanted to change how many minutes the rocket flew? We can add a parameter to the function signature, like this: def flyRocket with time in parentheses. We can also change the function body to use the variable time in its print statement, like this. Now, we can call it with a parameter. Let's say our rocket flew for 16 minutes. We can call the flyRocket function with that as its parameter. Then, the result printed to the screen will be: the rocket flew for 16 minutes. If we want to add additional parameters, like the color of the rocket, we separate those parameters by a comma, like this: def flyRocket with time, comma, color in parentheses. We can now include the new parameter, color, in the body of the function. If we wanted to call this new function and make a green rocket fly for 33 minutes, how can we call it? Try it now in your guided notes. Let's take a look at the code. We call flyRocket with 33 and green as the parameters. One quick reminder, make sure that the order matches the function signature. Since we stated that the parameters are in the order of time and then color, we have to match that order, 33 and green, when we call it. If we called it with the parameters green, then 33, it would try to fly a 33 rocket for green minutes. And that makes no sense. It's great that we now have the ability to print different messages based on our parameters. But what if we want our function to provide us with information as a variable instead of just printing it to the screen? That's where functions with return values comes in. Functions that return a value give us a value as output from a function. Let's create another function to calculate the time it takes for the rocket to fly a certain distance. Here, we define a function named calculateTravelTime, which accepts two parameters: the distance we want to travel in kilometers and the speed of our rocket in kilometers per hour. Then we calculate the time it takes to travel that distance, which is represented in hours. Here is the fun part. Instead of just printing the time to the screen, we use a return statement. A return statement tells the computer to give back the value as the output so that it can be used in other calculations. It consists of the code word return followed by a value. For example, a variable. If we called our function, it would look like this. Now our function will calculate the travel time, and when it is done, the myTime variable will have the answer that it passed back as output. Remember, whatever variable we set equal to the function calculate travel time will contain the answer. What are the benefits of using a return statement instead of just printing the variable? Well, we can still print it if we want to, like this. Or we can choose to do some more calculations with it, like convert the time to minutes instead of hours, and then display it afterward. If we had only printed the information, we wouldn't be able to store it and use it later, because variables that are created in a function cannot be used outside of that function. By using a return value, we let other areas of our program use a value that we return from our function. Let's see what we can do with our new skills by trying to solve a problem using advanced function signatures. For this example, we will be creating a function that will be used to determine if an astronaut is eligible for a mission based on their age and their experience. Write a function signature that accepts an age and an experience value. In the function body, if age is greater than 17 and experience is greater than 4, return true. Otherwise, return false. Try writing that function now in your guided notes. Here's the answer. We define our function named checkEligibility, which accepts age and experience as parameters. We then check if age is greater than 17 and experience is greater than 4. If so, we return true. Otherwise, we use an else statement to return false. Now we can call this function and use it to solve a real problem. We have an astronaut who is 35 years old with 7 years of experience. So we call checkEligibility with the parameters 35 and 7. We store the return value in the variable eligible. Now we can check if eligible is true or false, and based on the result, we can send them on the mission to Mars or state that they are ineligible. What will be printed when we use these parameters? Pause the video here and answer this in your guided notes. When this code is run, it will print, "The astronaut is eligible for the mission to Mars." Let's move on to trying another musical programming task. We've just found out that our spaceship is equipped with not just one, but multiple musical instruments. We've got guitars, pianos, and who knows what else is hidden in these compartments. Since we have more than just a guitar now, we want to play the same piece of music with different instruments. That's where our coding skills come into play. We need to write a function that can play a given note on different instruments depending on the parameter we provide. Let's break it down. We'll create a function called play that takes two parameters, instrument and note. The instrument parameter will specify which instrument we want to play, either the guitar or the piano. And the note parameter will indicate the musical note we want to play. Now, inside the play function, we'll use conditional statements to check which instrument we've specified. If it's the guitar, we'll call the play guitar function with the given note. And if it's the piano, we'll call the play piano function with the same note. By doing this, we'll be able to play the same note on different instruments, adding a touch of musical versatility to our cosmic journey. When you're finished with this exercise, try the other tasks in this section. In today's exploration, we unveiled the power of functions with parameters and return values. These enhancements equip us with the ability to shape our function's behavior based on input parameters and gather valuable output for further computations. Let's recap our journey. Functions with parameters grant us the flexibility to customize our function's behavior by accepting inputs or parameters during function calls. We learn to define functions with parameters by placing variables in the parentheses next to the function name and separating them with commas. For instance, we enhanced our fly rocket function to accept parameters such as time and color, empowering us to control the rocket's flight characteristics dynamically. We then discussed functions with return values, where functions provide valuable output that can be used for other computations. By employing return statements, which send back values as output, we transformed our functions into data generators, enriching our code's versatility. For example, we created a calculate travel time function that computes the time taken to travel a certain distance, returning the result for further processing. Armed with the knowledge of functions with parameters and return values, we were able to break down larger problems into smaller, more manageable parts. We used this method to tackle a real-world problem, determining astronaut eligibility for a mission based on age and experience. By crafting a function that evaluates eligibility criteria and returns a true or false result, we demonstrated how functions can be instrumental in the decision-making process. Be sure to complete the programming tasks, practice questions, and extension activities before moving on to the next lesson. And remember, in the universe of coding, the possibilities are infinite. I'll see you next time.